Hello there everyone, UXW Bill here once again with yet another appliance repair themed video. In recent times, an individual posted a comment on one of my previous appliance repair related videos stating that they did not have the confidence to diagnose or repair their appliance, and as such they were looking to acquire a second-hand refrigerator from a website such as Craigslist. It has been my goal with these videos to empower the average person to successfully diagnose and possibly even repair their household appliances, as despite their daunting appearance and sometimes mysterious workings, many appliances, including major ones, all base on the cumulative action of some very simple machines. All of these simple machines work on easily understood concepts, and they come together to create the greater whole. This person's commentary also reminded me of a video that I have been intending to make for quite a while now, diagnosing and repairing a very common problem with the typical frost-free refrigerator. This applies to both partially and completely frost-free designs, such as my parents' General Electric refrigerator that you can clearly see right behind me. And their refrigerator is, of course, suffering this particular problem, so throughout the course of this video, we are going to diagnose, disassemble, and hopefully, ultimately repair this problem. Now, you may be wondering what that particular problem happens to be. You may also be wondering how the defrosting action in an automatic frost-free refrigerator or refrigerator freezer happens to work. And the answer is very simply. It all starts out with a heating element that is mounted right around the evaporator coil. The evaporator coil in most frost-free refrigerators and refrigerator freezer designs is positioned between the bottom of the freezer and the top of the refrigerator. A fan typically blows air over the evaporator coil, thus cooling it and distributing it in unequal proportions to the refrigerator and the freezer compartments. Every so often, a cycle timer that is usually mounted at the bottom front of the refrigerator cuts in and disconnects the compressor from electrical power. After the compressor has been disconnected from electrical power, the heating element that is located near the evaporator coil between the bottom of the freezer compartment and the top of the refrigeration compartment is energized. And it is the heating up of that particular element that serves to melt the frost, converting it back into water. And that water in turn normally escapes through a drain tube that is located at the rear of the refrigeration compartment. It may sometimes be obscured by controls or ductwork or even the lamp inside the refrigeration compartment. The problem that can take place after many years or in a particularly poorly cared for or unclean refrigerator is that the water tube becomes blocked and it can no longer deliver the water tube to a pan that is typically situated in one of three places. The pan is sometimes located on top of the compressor, where the gentle heat of the compressor's operation serves to evaporate the collected water. Some refrigerators also place the pan at the bottom of the compressor, and yet other refrigerator designs use a fan that also cools the condenser coil in some cases to drive the water into evaporation by sending it up into a piece of wicking material or even just a pan that happens to be situated within the airflow of the fan. So that's how the automatic defrosting operation works, and one of its most common failures. Let's go ahead and take a look and see what has gone wrong with my parents' General Electric automatic frost-free refrigerator. We'll start by doing some basic disassembly. Before we actually disassemble anything, however, it's important to determine whether or not your refrigerator or refrigerator and freezer combination is in fact suffering from this particular blockage problem. The usual sign of a refrigerator whose defrost condensate drain tube is blocked is a buildup of water in the bottom of the refrigerator, and in particularly severe cases, this water can actually spill out onto the floor. It may also be possible at times to see a rusty trail where water has overflowed the drain and gone down the back wall of the refrigerator to pool in the bottom of the unit. Before we get started with this repair, let's have a word about safety. Whenever you're repairing an appliance or any other electrically operated item, your safety is of paramount importance. You can always replace an appliance or its component parts. You can't replace yourself, your health, or your own well-being. So whenever you work on an electrically operated device, be sure that you disconnect power prior to disassembling anything. And if the power for an appliance is switched in a location that is not near the appliance, be sure to tag the power disconnect so that no one accidentally turns it back on and gives you a potentially very nasty surprise while you are knee-deep in appliance parts. Appliance repair can be all of educational, entertaining, informative, and it has the potential to save you a lot of money. Just make sure that it's safe. Also, please note that while the author of this video presents his information in good faith, he can assume no liability for situations other than his own. In other words, you follow the advice presented in this video at your own risk, especially since the author has not seen every type of refrigeration system ever manufactured, and it's entirely possible that the advice in this video may not be suitable depending upon the equipment that you have. So please, think and carefully consider the results of your actions, and never be ashamed to call in a professional if you are in over your head or you don't understand what's going on. It's better to get help than it is to get hurt. Here we are right now at the back side of the refrigerator, and what you are looking at is the basis of the refrigeration system. As you can see, this refrigerator is of the second design that I talked about. It's actually a hybrid design. The compressor sits in this pan, and right next to it is the condenser fan that serves to not only cool the condenser coil, but also to evaporate water that collects in the pan. Now you might question the wisdom of a compressor powered by electricity and a fan being placed in this pan, but it's something I've certainly seen done many times in the past, and I've never had a problem with it along the way. Something like this does, however, underscore the extreme importance of making sure that your refrigerator is plugged into a properly grounded outlet. Now, one thing you will notice right away is that this particular tray is not only dry as a bone, it's also got a pretty heavy helping of dust in it. So we can say pretty safely that this defrosting operation has not been working properly in this refrigerator for a very long time. And in fact, you can see the defrost tube going into the pan right here behind this fan. If we follow this tube up the refrigerator, we'll see that it stops right around the middle, just around the separation between the refrigeration and the freezing compartments. And we'll need to get at the other side of this connection in order to diagnose what's going on here. Now, unfortunately, one thing that potentially complicates the repair with this particular refrigerator is this sort of trap that has been molded into this plastic. If there's a blockage that's developed in here, the usual fix is to run a stiff piece of wire down through this tubing. But this trap may frustrate our efforts to do that. We may actually have to use something like hot water or compressed air in order to solve this problem. I have also noticed that on this refrigerator, it appears that there might be two drains. You can see there's a white plastic piece that's just touching the edge of the compressor there, and I have seen water dripping out of that. That one might be an overflow for the ice maker. I'm not really sure exactly what that one's purpose is, but you can see that there is water dripping out of that. Unfortunately, you can also see that General Electric's decision and method of grounding for this particular refrigerator and its compressor has the potential to get a little bit flaky over time, especially as much as the compressor mounting plate has corroded in this case. So it might not be a bad idea, if you find something like this on your refrigerator, to disconnect that ground and clean things up before you continue, because the safety ground is very, very important and anything should ever develop a short. I can tell you a story about how that happened once with my grandfather's refrigerator. It was plugged into a non-grounded outlet, and the heating element in the ice maker corroded to the point where the live parts were energizing the cabinet of the fridge. My aunt, the one who drives the Volvo, happened to discover that fun little item when she touched the refrigerator and the stove at once and got quite a belt that she soon did not forget. Took me a little while to find the problem, but as soon as I got the ice maker out of there, I knew that was what had happened, and that is why it is generally a very bad idea to float the safety ground on an appliance. You never want to cut off ground pins or anything else. But as I said, I was talking about this plastic tube right here, and you can see it runs up through this metal channel, which is kind of pulled away from the back of the refrigerator, and it terminates somewhere in the freezer compartment. However, I do not think that this tube has any problem because there's water running down it, and it's also much less likely to plug given its location in the back of the freezer compartment. So let's go ahead and take a look inside the refrigeration compartment. Alright, I've gone ahead and started the repair here. It's very easy to get started, although the exact method you will use will vary somewhat depending upon how your refrigerator is manufactured. Every refrigerator manufacturer tends to do this a little bit differently from all of the others, and General Electric's approach, as well as that used by Hotpoint, is actually fairly unique. And this is about a 1994 era refrigerator, so right around 20 years old. But that's really nothing for a properly designed refrigeration system to do throughout the years. Now, as you can see, I've not gone ahead and disconnected power just yet at this early stage in the disassembly, mainly because I'm using the refrigerator's light to provide a little additional illumination for the camera so that we can clearly see what's going on here. The thing that we need to do is to remove this trim panel, and you will probably have something similar but not exactly the same in your own refrigerator. You may also have to remove some of the controls and wiring, so make sure if there's any question about how any of this goes back together that you take photos, or you record video along the way, or even take copious written notes. When it's time to put everything back together, you will thank yourself the more you do along those lines. Alright, let's see what we've got going on here. We'll go ahead and remove this cooling knob. And I should point out that blockage of that tube that you saw in the back of the refrigerator just moments ago is not the only reason that it can get plugged up. It can get plugged up by frost too. Anyway, we'll go ahead and remove this control panel here, and things are becoming a lot clearer already. One thing you will see right away, and this is the case with most automatic refrigerator and freezer combinations, is that the refrigeration and freezer compartment temperatures are determined primarily by a thermostat that's situated in the refrigeration compartment. The freezer temperature, in turn, is governed further by this duct over here. And as you can see, if I operate this little wheel here with the letters on it, the position of a duct changes. And that duct governs how much cold air is forced into the freezer compartment and how much is allowed to continue on down to the refrigeration area. So very simple and very, very effective. Unfortunately, it does look like we're going to have to take apart some of the electrical wiring in this refrigerator. It does seem that General Electric has made that decently easy for us, because they provide some nice plastic connectors that can simply be pinched with those tabs on either side to release them. However, one thing we will want to be very, very careful with, and you'll probably find one of these somewhere in your refrigerator as well, is this thermal sensing bulb back here next to that styrofoam cutout. If you break that or pinch it, the thermostat in your refrigerator will no longer work correctly, and you will have to replace it. And that makes the cost of this repair go up quite considerably, depending upon how reasonable your refrigerator manufacturer is about pricing replacement parts. But before we can go any further with this, we need to disconnect power. Again, safety first. Now, I have most certainly shut off power to this refrigerator by disconnecting the power cord, and because it's within my range of sight, there's no chance that someone's going to sneak up behind me and plug in the refrigerator while I'm least expecting it. But if your refrigerator by some chance happens to be hardwired or part of a built-in installation, you might want to go ahead and take this opportunity to tag the fuse or circuit breaker that protects its circuit so that no one happens to energize it by accident and give you a very nasty surprise. We have, of course, lost the help of our little light bulb, so here is where some external illumination from an old desk lamp comes in real handy. Now, we're not quite ready to undo these screws back here yet. I find it interesting that they've got nut-style heads on them. Instead, we're going to disconnect this wiring harness, and we don't want to get too rambunctious with this because it might break. A lot of these parts are pretty fragile. Now, this one was pretty easy to remove. I'm actually impressed, as old as this refrigerator is, that some of this plastic is not very, very brittle. But your mileage could most definitely vary, so be careful. We'll go up here and see if we can disconnect this one. It's looking like it might be a little bit more difficult to do, but nope, not much. Now we should be ready to go ahead and remove this thermostat assembly from its normal resting place. And some of these screws could be quite tight. It might not be a bad idea along with the bevy of tools that you have undoubtedly brought along to do this particular job, to also bring along a small magnet in case a piece of hardware happens to fall down into the nether regions of the refrigerator, where it will undoubtedly become very, very difficult to retrieve. Now, one thing I'm seeing here is that we may have hit a complication. This refrigerator is not designed like others that I have worked on in the past. It looks like the drain is actually up in the freezer compartment. So I may have to change the focus of my activities here and actually turn my attention to taking the bottom out of the freezer compartment and checking to see if something's got that plugged. You can definitely see there's a fair amount of water buildup here. I don't know how much of that is actually condensation because of the temperature variable between the freezer compartment and the refrigerator, and how much of that is trapped water trying to get out. But you can definitely see how water has overflowed this and gone down into the refrigeration compartment. Though again, it looks to have taken a different pathway than I would have expected. It almost looks like it came down through the ducts. And in fact, you can see, or I just saw, a droplet of water fall off of there. So I may have to change my tactic with this. Like I say, I've done this many times before, but on all of those refrigerators, this particular item was accessible from the refrigeration compartment. So we may have to change our tactic here. In light of what I've recently discovered, I've gone ahead and started to dismantle the freezer compartment walls inside this particular refrigerator and freezer. In the case of this particular model, that's not too terribly difficult to do. The first thing I did was I went ahead and removed the ice maker. And the ice maker is ordinarily pretty easy to remove, and yes, I know there's a wire peeking out of there. You don't need to tell me. Most of them are held in by 2 screws, and you don't even have to back them out all the way. You just have to back them out enough such that these brackets can clear, and then you can disconnect the wiring from this unit and proceed to remove it. Now you should be careful because this thing could be full of partially formed ice cubes, or if it's just recently ejected a batch, it might actually have raw water in it that could slop all over the place and make quite a mess. I've also gone ahead and removed this duct here, which I believe draws cool air across the ice cubes in the ice maker to try and make them form a little faster. And I have made a most interesting discovery, other than to say it's probably time to clean the freezer. I'm running out of places to set things here. I wouldn't be surprised if something goes crash on the floor here very soon. It's oftentimes a good idea to have sufficient extra refrigeration space when you're working on a repair like this. I could take this stuff all out to the garage refrigerator, but I don't think I'm going to be long enough that this is going to be a particular problem. Now the ice maker also has a water tube leading into it, and I'm sure there are some of you who have noted the proximity of the electrical connection to the water tube. You'd be right, that has the potential to be dangerous. Just another reason why it's a very good idea to never defeat the safety ground pin, and what's more important, to make sure it's hooked up in the wall to something that actually corresponds to ground. Because if something ever went wrong, it'd be very easy for the metal cabinet of this refrigerator to become electrically live if it's not properly grounded. I've discovered that I think someone's been in here in the past, because up here at this opening, this air grill, it looks like there's a space for a screw, only there was no screw there. And one of these plastic clips that holds this metal wall in place is actually broken. The other one's still intact. So we're going to go ahead and release that. And that lets us pivot down this back wall of the refrigerator, the freezer compartment. And right away you can see the majority of the workings right here. This is the blower fan that circulates air through the entire unit. You can see how that's designed to work. You can also see that those blades are fairly wet with condensate water. Again, safety ground. You can also see that there's a fair bit of frost built up on these coils. Now ordinarily that might make a person a little bit suspicious, but I don't know when last this thing did a defrosting cycle, and I would assume that since water is building up in the bottom of the refrigerator, that the defrost heater and the timer are most assuredly working correctly. But if you found that these coils were coated in frost, you might be the victim of a timer that has actually stopped working. And what we're going to do right now is we're going to take some warm, most definitely not hot, no hotter than what you can get out of the average hot water tap at your kitchen sink or wherever you get hot water from. And we're going to pour it over these coils because the drain area is right underneath them. And we're going to see where it turns up at. I had to stop the video there. I was almost the victim of a drive-by fur heading. What? In case you're doubting me. He came in here and he's a heck of a salesman. He offered me a good deal on a 98 Jeep Wrangler.
I mean, it's so good of a deal that you're going to have to walk away from.
Oh. Okay, I just finished pouring almost the entire cup's worth of hot water down those evaporator coils. And I heard the water go trickling into what should have been the drain. So let's see if it actually made it all the way down and around back there. It definitely seems to have. But it looks like we've got another problem here. Looks like there's a bit of a blockage there because it's overflowing and it's dripping on that capacitor, which is not at all a good plan. And nothing whatsoever is coming out of this rubber tube. So this bad boy must be completely plugged up somewhere. We're going to have to find out where. And it's looking more and more like that may not be a whole heck of a lot of fun to do. But fortunately, I have an idea here. When you can't win, cheat. Or as I sometimes like to say, eagles may soar, but weasels, the animal, not Weasel 2 HTM, do not get sucked into jet engines. What we may be able to do is to simply take this hose loose from its mountings and blow pressurized air through it from an air tank or a compressor, maybe even one of those difluoroethane cans, duster cans that you see for sale in stores, would even prove to have enough wallop to solve the problem. But I kind of doubt it. We may have to get the air compressor out of the new garage and bring it over here. But before I reach that conclusion for certain, we'll go ahead and see if I can get the bottom panel of this freezer to come up and reveal a little bit more of the workings of what's going on in here. And maybe I can find that drain at long last. I'd be very surprised if it's not visible, although I'm starting to wonder if that's not the case. Okay, I've continued testing theories here to try and get a better idea of what's going on in this particular refrigerator's design, because as previously mentioned, it's definitely a bit different from anything that I've ever worked on in the past. And after about 2 more cups of hot water, I think it can be safely said that I have definitely had a breakthrough. Let's go ahead and take a look at the back of the refrigerator here and see what's going on. You can see there's quite a bit of water on the floor now. I'll have to clean that up. Of course, probably be a pretty good time to clean the whole of the floor. I'm way overdue on doing my scheduled refrigeration system maintenance here, blowing the dust out of the condenser coil and things like that. But as previously noted, I happened to notice that water was dripping down from this thing, which probably isn't even any kind of a condensate drain, and it was dripping on the run capacitor. And it definitely should not do that. That's one way to make your life a lot more exciting right there without you even knowing it. Like I said earlier though, safety grounds, they really matter. I happened to notice something as I was looking at the back of the refrigerator here, and for those of you that are more familiar with General Electric refrigerators than I am, you're probably saying at this point, hey you dum-dum, you should have done that first. Well, guess what? I didn't know that it was possible until I noticed that there was water seeping around this particular plastic formation. And that's when I reached around and I grabbed it and I gave it a twist. And I discovered that, much to my amazement, it comes loose. I also discovered that it might be time for everybody all at once now, and I hope you just haven't gotten back from eating, going to a restaurant or anything like that, because I believe that it is probably time for everybody to get together and give me a nice big collaborative ew. Look at the sludge that has built up in there over the years. Some of that's invariably just nasty stuff that was growing in the water. Some of it's food spills and things like that. Oh, but it gets better. Every one of these projects always does. Let's go ahead and take this over to our light here where we can really see what's going on. Well, it must have slid down. But just a moment ago, that thing was phenomenally, clearly plugged. And you can see that even when I hold it up to my light, although there's a curvature in it, I would still think that some light would get through that. But there's no light making it through that puppy at all. So it is in all likelihood completely plugged. What that means though is we can go over here to the sink and I can turn the water on and wait for it to warm up. We can test to see how waterproof handy cams are. Did you see that? Not draining at all. It's just completely plugged up solid. Could throw this in the dishwasher, could go blast it with compressed air. That might actually be kind of fun. Could try running a wire through it, something like that. But I say you're just not getting any work done unless you manage to make at least one big mess along the way. So let's go downstairs to the laundry tub and see what I can do with this crazy thing. Now, for those of you who are not too familiar with my videos and the various things that I do and the beliefs that I hold, let me start by saying that laundry tubs are just plain awesome. And I feel sorry for anyone who has grown up or currently lives in a house where laundry tubs are not standard equipment, because you don't know what you're missing. These things are great for cleaning all kinds of stuff, from boots to computer parts to nasty appliance valves that release condensate water. Amazingly enough, I've never actually done laundry in the laundry tubs. Done it in the bathroom sink a few times with some Woolite. What I have right here is one of the greatest contraptions ever known to man. This thing allows you to spray water all the way across the room if you turn the valve on too fast. Faster than you can say, oops. Fortunately, this is an old washing machine fill hose, by the way, if you're wondering about a project for them. You can attach it to things, and you can really put quite a bit of pressure through here, and hopefully power out any kind of a blockage that happens to be going along. Either that, or I will proceed to get myself soaking wet in an expedient manner, and you will all get to learn some new words that you've never heard UXW Bill use before on his channel. So let's get started, shall we? Because chances are, if you're not trying to break, soak, or damage anything in your projects, you're just not going about them the right way. So let's go ahead and try this. By golly, we've managed to force some water through it now. Some is good, more is better. I'm inclined to go ahead and let that go for just a few minutes, you know? Just to get that thing good and cleared out, because I just assumed it was another 20 years before I ever had to do this again. I've decided to be exceptionally thorough in my pursuit of cleaning out the blockage on the condensate drain tube in this refrigerator. So here's the actual drain tube itself. We can try holding it up to the light, see if it's blocked. Certainly looks like it could be. There's some light getting through there. I don't think it's blocked, but we'll play it safe anyway and go flush it out under pressure in the laundry tub. I gave both the pipe and the flow direction piece a very good flushing out down in the laundry tub. They now seem to be clear. So I turned my attention to this hole here at the back of the refrigerator, and you can see I'm not quite through with it yet. But it took me a while to figure out what I could use as an acceptable implement to clean that out, because you don't want to get too rambunctious with any of the various parts of your refrigerator, because replacements are probably going to be expensive. So I took this table knife and I discovered it was just the perfect shape to fit in there. And again, I hope you haven't eaten anything lately, because that's what I reamed out of there. It's pretty gross. It's like an appliance's version of a nose. It actually doesn't smell like much of anything. Not that I've put my nose very close to it, because I'm not the strongest stomached person that I know. We'll go ahead and see if I can get this cleaned out, although there was blockage in here. It clearly wasn't the entirety of the problem, because when I undid that piece and twisted it loose, the water flowed quite freely through here. Although, despite the large volume of water that ran out onto the floor, it was not enough to push that gunk out of there. So we're going to go ahead and flush it one more time, just to try and clear that out. Look upon my work, Rube Goldberg, wherever you happen to be these days, and be proud. That is, if you can see it. That actually worked quite a bit better than I expected it to. I really thought at the first provocation it had that water bottle would fall off there and make a mess on the floor again. But it actually stuck around, and we caught us some crud here on the crud patrol. Now that this is back together, I've gone ahead and flushed it several times with water, and it definitely has made a difference in that now the anticipated result, no matter how gross it might look, is actually taking place. And I have noticed there's still a little bit of leakage going on back here, but under normal circumstances this thing is really not going to be dealing with as much water as I put down it. It still might not be a bad idea to go back and hit this thing with maybe some sort of RTV sealant or something along those lines, just to help it stay leak-free. I'll be keeping an eye on it in the future just to see what happens, because it's still dribbling just a little bit outside of that round opening, and I'd rather it did not do that, although it certainly looks like it's had plenty of time to do that very slowly over the years. So like I say, just going to keep an eye on it. But the natives are starting to get restless. They're wanting to eat and do other similar things that normal people like to do, so I've got to go ahead and get this crazy thing put all the way back together and get the stuff that normally goes in it back in there where it belongs. Assembly, as they say, is pretty much the reverse of disassembly, but no, I'm not going to leave you with a cliffhanger like that and end the video and thank you for watching and encourage you to leave a comment if you have one. Instead, we're going to go over the delicate ballet of putting this refrigerator back together. Now, the first thing to do is to go ahead and put this rear panel back in place, which is not too terribly hard to do. The thing that we have to be aware of at all times is the wiring, and you want to pay attention to the way this is routed and put it on your notes so that you can put it back exactly as the manufacturer had it. And you might want to be careful when you do this, because this wiring can be razor sharp. This metal panel can be razor sharp and it'll slice you open, so if you haven't had a tetanus shot in a number of years, you might get one after fooling around in here if you're careless. So be careful, folks. Also, do not get too rambunctious with the refrigerant tubing, or you're going to be in the market for a new refrigerator, or at least the repair bill for the one that you currently have. Now, the next thing I have to do in order to put this back together, and I may have to shut the camera off to do this, is to go ahead and put the ice maker connection back in place. That actually fits in this diamond-shaped hole here. But we'll see if I can do this with the camera running. More importantly than that, I hope I get it into place properly. I'd hate to have to take this thing apart and do it again. We want this piece to lock into place here, and at present it's not being too agreeable about actually doing that. So I may have to fiddle with this a little bit to get it to go in there properly. Sure enough, the magic word was just to turn the camera off and work with this thing directly, and it snapped right back into place. We're just about ready to flip this metal shield back up in place and conceal all the magic that makes the freezer work. But before we do, we want to be very, very careful in putting things back to make sure that we do not chafe or abuse any wires, because that's a good way to cause a shock hazard or to trigger quite a surprise when you put the unit back together if a chafed wire is going to ground, and once again, the unit is properly grounded. It's time to go ahead and put this duct back into place. It actually has an instructional legend on it. It says, arrows left for ice maker, arrows up for ice tray. Fortunately, we are cultured people. This is high living right here, folks. And we have the ice maker kit installed in this refrigerator. First fridge we've ever owned that actually has an ice maker in it. Speaking of the ice maker, here it is right now. It's time to go ahead and hang it back up in here where it belongs, but in order to do that, we have to plug it into power. And you might be wondering why that's a 4-pin connection. Well, 2 of those pins are the hot and neutral for the 120 volt AC power line, and the other 2 are provided so that this thing can trigger the solenoid when it needs to send more water up here. And of course, prior to clicking this back into place, I might try to find a screw for it at some point because it doesn't fit quite as nicely as it did in the past. It shouldn't be too hard, just a simple machine screw ought to do for that. This is actually the water tube, and you have to run that carefully into place. Otherwise, every time the freezer requests water, the ice maker requests water, that is, it'll spill all over the inside of the freezer, and you certainly do not want that. There's a little protective cover that actually has to go back into place if your unit is equipped with an ice maker, as this one is. So I'll go ahead and dovetail that into place, and we'll be just a little bit closer to being able to plug this thing in and seeing if it works as it should once again. There's the freezer compartment looking just like it should once again. So let's go ahead and turn our attention to the refrigeration compartment. Go ahead and put everything back together in here. Since we didn't have to remove very much, you can see how that water has kind of dripped down as this unit has defrosted. A lot of water involved with refrigeration. I'm sure many of you have certainly figured that out by now. I was afraid that might have come completely out of there. Fortunately, it seems to be going back in there just perfectly now. wouldn't get too rambunctious with this either. You may have noticed a common theme here. Don't get too carried away with the stuff that makes up your refrigerator because it may not be rugged enough to stand it. These screws in particular look like they're going into plastic threads. And while you could easily rethread them, it would still be an adventure and sadness that most people would rather not take. So let's go ahead and plug these wiring connections back in. They don't seem to click into place very affirmatively, but it did go into place. Alright, should be good to go with that. I'll get this plastic guide. Yeah, there's something flapping around in there. Just an insulating point to help keep those wires out of mischief. We'll go ahead and press this thing back into place as it needs to go. Okay, here we go, folks. It's time for the smoke test. So let's see what happens. Countywide power outage, 6-foot flames, a refrigerator that's left a refrigerator size shape in the roof when it exploded. Here we go. Let's see what happens. Let me plug this in. Alright, nothing blew up. It's always a good sign. We've got our light on once again. I went ahead and turned the thermostat off just so that it wouldn't try to start up while I was plugging it in. So let's go ahead and turn it on and see if it actually starts up. And it did. Sounds like it's running very nicely. We'll go ahead and do a check inside the freezer compartment here. With the fans running, everything seems to be accounted for. The ice maker will undoubtedly cycle whenever it happens to need to. And hopefully, that will be the end of this saga for a good long time to come. So if you've made it through this entire video, thank you for watching. I hope it has proven useful to you, and feel free to leave a comment if you have one.